Okay, so first thing first, I hope you must have received solution of all the previous assignments, right? And I hope you have matched. So any issue did you find still?
Yes, sir. Up to six assignment, we have sent a query related to the discussion forum.
Yes.
That is related to the assignment number 4, question number 5.
Assignment number 4, question number 5.
Yes, sir.
Okay. And you have matched solution as well, and you found that it is wrong.
Yes. Actually, my answer is 247,
Uh-huh.
and the range is acceptable 230 to 260. But I didn't get any marks for that. It's all.
You are referring to week 4, question 5, right?
Yeah. Assignment number 4, question number 5.
Yes, find the stated transfer phase, right? Started starting average 251 and service. Okay, I'm not presenting my screen, is it? Yeah.
Yes, sir.
Yeah, so I hope you are seeing my screen now. Two
Yes, sir. Able to, yes, it is
fifty.
visible.
So how much did you get? Two,
Yes, I'm getting two, 1 minute. I'm getting 247.
247. Yeah, so it is within the range.
Yes, sir. But still it shows it is wrong.
Then I think that must be resolved from the discussion forum itself.
And despite of me, another one person has also have the same issue. I think so.
Uh, okay, Chitu, you are referring to?
Maybe.
Chitu, you have also the same issue?
Uh, 1 minute, sir. Actually, someone has comment me one. Rajni, Rajni.
Rajni, yeah, yeah.
Yeah, yeah.
Okay. So this was any other like any concept based incorrect questions or something apart from this problem. This is the range issue. I think they will sort it out.
Okay, yes, sir. And despite of this, there is another question that is in a week number 3,
Week number 3, yes.
assignment number 3, question number 2. In that case, we have to find out the angle, the pitch factor we have to, and in this, what is the angle?
Yes.
So that
And
answer, yes,
yeah, this one I guess.
yes, yes, yes.
The
The my
angle
answer
is
is 15 degree. Yes,
15
one.
degree. Yes. It was a doubt that day during that time.
Yes, sir.
Factor. It should be alpha by 2, right? And Alpha here should be short pitch angle.
Equation is cos n alpha by 2. Yes.
Yes, yes, you are correct. So here it is. This. Let me note down all the questions. So, like for question 5, second week 3, question 2. Yeah, any other from this week, this assignment?
Not, no, no from this assignment. Another.
And last week we were facing so many incorrect answers, right? Rajni is there. Rajni, have you matched your solution from the last week?
Yes, sir. In that there is a yes, sir. Actually, in that case, I have a one question. Ki
Yes.
suppose we are drawing a geometry, one-fourth geometry.
Mm-hmm. Yes.
Okay. Yeah. And
Uh,
then once we will get the answer, we should multiply by 4, na?
no, no, no. That's what I explained in the last session in great detail with the help of simulation also. That
Okay.
why we simulate with symmetric factor to reduce
Hmm.
the time, right? But it should give
Okay.
you the exact same value what the full model should provide you.
Okay.
So I think you
That
can
is
go
I'm
to
getting, but I'm actually the understanding of the question is me. That is I got. Ki for the save of the time and for whatever the we say, for example, we one-fourth part of the geometry we
yes.
simulate, and yes, we are getting the answer according to only one-fourth. Okay, so if you want to find out the final answer, means the full geometry,
Mhm.
then we have to multiply by 4, now.
Uh, if you want to, sorry, could you please repeat the last line? What did you say? You,
Yes, my what is my understanding that for the time saving and etc. we are doing only one-fourth part of the geometry and we do the analysis for one-fourth part only. Okay, so whatever the result we are getting, it is for one-fourth part. That is okay. But if I want to find out for the whole machine, okay, then we
uh,
have to multiply by 4, na?
no. And I can see here answer is also incorrect. 1/4. It should not be 1/4. Why?
Hmm.
You have simulated any model, right?
Okay. Yes.
So if you have simulated FEM model, then you could see only flux lines and all those things for 1/4. But
Yes, sir.
whatever torque waveform you will get, or whatever flux density waveform you will get, that will be that will be for the full model. Let's
Okay.
say you are designing a motor for 10 Newton meter torque, right?
Yes,
So
sir.
you will design and you will parameterize it according to the 10 Newton meter. So you have
Yes.
all the parameters for 10 Newton meter. Now just you are modeling for 1/4 part so that
Okay.
you can get it quickly.
Okay.
But
Yes. Yes.
but uh, but if it doesn't give you 10 Newton meter, then what's the point?
Hmm.
So for that, I think you should simulate a couple of more simulation models based on
Hmm.
any open source software. Which software do you use?
I'm using ANSYS.
ANSYS.
Actually, yeah, and actually we have a license of MotorCAD.
So MotorCAD is a great tool to learn. Haven't I did so in the last session. Great
Yes.
detail. I'm opening MotorCAD for you. So, and you are familiar with the symmetry option in the MotorCAD?
Yes, sir.
So then you simulate once with symmetry factor
Hmm.
and then simulate it with full model, right? Here, if you go in the setting, in the calculation, here is the symmetry, right?
Yes.
So here you provide symmetry, right? How much symmetry factor do you want? And or symmetry which is default by one pole pitch and one pole pitch basically. So if you simulate, you will get Very right. See, this is a symmetric for one pole pitch. Okay. So carefully see here, torque is 10.9 Newton meter, right? Graph is
Yes.
almost like this. Now, if I simulate it with full model, see,
Mm.
so it doesn't imply that the torque will be multiplied by 2, right? It is
Yes, yes.
just
The
to,
torque output will be remain same. Either you do the
yes,
1/4 symmetry or whole. Yes, sir. Got it now.
yeah, yeah, yeah. So here I don't know why solution is also incorrect provided. I don't know, this should not be. So which option, if you have selected 1/4, then it may be correct for the time being, but I don't think it should be correct option.
Yes, actually, I have selected four, so that I can understand that is my wrong answer. Yes, sir.
Okay, 4 is anyway.
Yes, but in that question number, yes, seven, question number seven, sir.
Yes.
In the summit 11,
Hmm. This
yes.
one, right?
So in that,
Uh-huh.
yes, the my answer is 26.73.
Yes, yes, yes. 26.73. Let me verify. Last week we were
I
solving
think
this.
in last solution also we are getting.
Uh, no, 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 no. Actually, in last year's assignment, I think the value was 26%, but actually
No,
what
no,
we
but
were
actually,
getting.
sir, I have put the values correctly.
Hmm.
Say, for example, here 150 mm is given. Okay.
Hmm.
And the speed is given at 20 meter per second.
Okay.
So I have converted this 150 mm to a meter.
Okay. Okay. Yeah. Yeah.
And then I have put as a x1 the
Yes.
diameter, bore diameter. So x1 I have put in a meter and the
Hmm.
x2 is 20. So if I will put in such a way, then I have calculated thrice, but I am getting still the same answer, 26.73.
Hmm. I think you are correct there. If you put in terms of meter, I think we were also getting 26.73, right? 26.73 you are getting, right?
Yes, sir.
So, in the last session, we uh, went through this question, right? And first time I also solved with the x1 in terms of meter. But later on, what we observed that, in the question, x1 is provided in terms of millimeter. And uh, we referred ki we should move ahead with only because these kind of equations, whatever is formed, generally such a designs are based on MMs only, right? So that is why people take directly this value. But anyway, you could dispute this question. You could raise a dispute for this question because
Hmm.
if one parameter is given in mm, other parameter is given in meter per second, then it will
Yes,
be
sir.
confusing for many. So you could
Yes.
raise a dispute for this.
Yes.
But for Chitu and Rajni, I guess it must be correct because in the last session we had discussed and it must be 87 we were getting. So I think you might be getting correct answer. Okay, yeah, you were saying something else, Dr. Krishna.
Yes, sir. And one thing, 1 minute. Sir, in week number four,
Mhm.
one answer I'm getting a partially correct.
Okay, week
The
number
question number four, sorry, assignment number four, question number eight.
number eight. This one,
Hmm.
this is a theoretical question, right?
Hmm. One second.
Okay.
Yes, scrolling and cogging. Yes, this one. But sir, we are not able to select two at a time.
Okay. Okay. So how much marks did you get for that?
Point 0.5.
0.5.
Yes, sir.
That's weird. Maybe they might have, created this question on the template of single correct answer, and that's why
Hmm.
that issue might have happened. So yeah, for this also, let me uh, before that, which one? 11th week, 11th, 7th. I could write. I am noting all those questions which had issues so that I could also post on the forum, and
Yes,
I could support your arguments that
yes, sir.
you guys are
Yes, sir. So in this assignment number 4, we have a query regarding the question number 5. Okay, and yeah,
question
that is
number
we have discussed assignment number 4, question number 5.
5 also, right?
Yeah, Miss Rajni, I don't know. Rajni has also have this, I think, same issues.
Okay, I think she has some mic issue today, so that is why she is not able to speak. But yeah,
Hmm.
I could remember some questions.
Hmm. So, sir, if possible in this assignment number 5, so if this question number 5 is correct and this partial is correct, then it is helpful to us to get these marks 100.
Sure, sure, definitely.
Yes, sir.
Quick for question number first. Option issue, right? So question 8. This one. So in 5, how much you are getting? Like you were getting
Yes,
how
sir.
much at that time? I couldn't remember the value. How what was the correct answer for question number
For
5?
which this one, na, question number
Uh,
5, na, sir?
yes,
Ha,
yes.
that is 247.
247. Yeah, exact half, I
Yes.
guess, right?
Yeah. Stator turns per phase.
Hmm.
247.
Yes, right.
And in this scrolling and cogging, both we
Yeah,
are not able, we have to select anyone. Yeah.
yeah. I have noted both the things.
And that question alpha is 15, means x is 15-degree pitch
Yes,
factor.
yes.
Yeah.
Any
And
other
sir,
question?
yes, sir. I have just a question that in the final examination,
Hmm.
whatever the pattern of the assignment, maybe definitely maybe the question will differ, but the pattern is like the same, or the theoretical questions have a some percentage of weightage, and this numerical have a some percentage of weightage like that.
Yeah, like that only, I guess. Yes.
Hmm.
It's a combination of all MCQ, numerical, and theoretical questions.
Okay. So we have to write down the descriptive answer in that case, sir.
Uh, it is computer based, right? It is computer
Yeah.
based exam, only computer based.
Yeah.
Then I think it will be similar to in computer based. I don't think because
Hmm.
I had taken a long time back now. Many things have changed.
Yes, sir.
I'm not sure about that, but if someone has, this is your first NPTEL course.
No, actually, I have done previous NPTEL course,
Hmm.
but in that case, the same pattern was there, but the theoretical we have to not write down the descriptive question, but it's too long time. I think we have 2013 14 around I have given.
Yeah, no, so things must have changed a lot by now.
Yeah.
Uh, if it is a computer-based test, like you have to go to TCS I1, right?
Yes, sir.
Then I don't think you will have a descriptive question to write, but you
Hmm.
will certainly have numerical kind of problems like GATE exam. Like you will have to solve the problem, like
Hmm.
numerical answer type, NAT type. Like you have to enter the only final answer value.
Okay. Like this key, ABCD MCQ is given, and we have to select any one, or we have to type the numerical value, any one. This type.
There will be two types of question. Okay.
Hmm.
One is
Hmm.
this kind of questions where MCQs will be there.
Hmm.
The other will be like a problem, a statement will be given. You
Hmm.
need to solve on your rough paper or wherever you want, and
Hmm.
only final value you should plug in into the that
Entering.
box. Yes.
Yes.
So you just have to type the numbers.
Yes. And I think this is our last discussion for session.
No, after this, I think one more discussion session is there on Wednesday or something.
So that will be helpful. Yes, sir.
Yeah, one more session I have scheduled. Just, I just forgot that on which day, but it must be
Hmm.
on Wednesday. Let me check once.
Wednesday is 16 and then 23.
Exam is on.
Exam is on 27th April.
Okay, so what is you are saying? 16th and 23 is?
23. You said na Wednesday you have arranged.
Yes, yes.
So yeah, so there are now the next Wednesday is 16 and then that after 23, 23rd.
Okay, yeah. So no, it is before this. Just a sec.
Okay, sir.
I'm looking into it. So it is before. Okay, so I think it should be next week only, means this coming week. But anyway, you guys will definitely receive an email
Mhm.
stating all the details.
Yes.
Okay.
And one thing more, sir, is I'm working on this FEM. So in future, if I have any issue regarding any software, means small queries are there.
Mhm.
So is there any possibility to contact you?
Definitely. I think I must have provided my email ID and contact number. Anyway, I'll write in my chat box, so
Okay.
any of you could connect with me anytime.
Yes. Sir. So please. Yes.
Yeah. Yes. So I have posted my email ID and contact number in the chat box. So whenever you feel anything, please feel free to contact.
Yes.
Okay. We were having so many incorrect options in, I think, week 10 or 11. Chitu, you are also silent today. Your mic is also not working.
Sir, my mic is working, sir. You both said conversation, so I thought of letting keep it for some time. So
Sorry,
I'll
sorry,
keep it.
sorry. Your voice is breaking. I couldn't get.
I hope so. My voice is clear now.
Hello. Yes.
Sir, are you able to hear me?
Yeah. Like it is breaking in between, but I could hear you. Yeah, Chitu, please repeat.
Yeah, Dr. Krishna Patel was asking their doubts, so I thought, okay, let me also listen.
Okay, okay, okay. No issue. But we had doubts from week 10. Yeah, Rajini also messaged. From week 10, we had doubts.
Yes,
Which questions? Electromagnetic torque I could remember. 0.8 to 0.9. Let's have the so this value is still not corrected, right? Last question. This 10th. It is still 0 derivative plus 0.2 omega over dt. Yeah, it should have been 0.2666, right? So it is still not corrected.
0.533. Rajini ma'am, what your answer is?
Two into two. Okay,
Sir, I am getting 0.533 in that case.
I could also remember like that. 0.2 plus 0.333. Let me calculate it.
Yes, I am getting this answer.
Yeah, so 0.533. I think we discussed it last week. So the correct answer is 0.533. Question number 10, the week 10. Yeah. Okay, so
In that case, we are getting a wrong answer. Means our answer is wrong.
Yeah, apart from 10th, were we getting incorrect in
Yes,
7th as
apart
well?
from 10th, yes, I have a query. For 4th, what is the answer, sir? The stepping rate.
273.42.
Okay.
Yes, into.
I didn't know how I get 8.646.
Yes is given into 386. Just might be calculation mistake, I guess. Right, Chitu? This answer is correct. Question 4th. Inertia, they took wrong value in question 4. 0.539 into.
Rajini ma'am, what answer you are getting for 4th? Zero 0.539.
Still, it is coming out to be.
Up to 4 0.
Sorry.
Tell me.
Sorry, I don't think you are audible, Chitu. today some issue with your audio there. But I calculated, I think it is 273.42. It's coming correct only.
Yes, sir. Yes.
Yes. Dini, you were referring to the same problem where regarding inertia? Oh, no, you were referring to the last question. Yes. Okay, so this is correct. Dr. Patel, you could verify now also.
Yes, sir.
You will get 273.42 only.
Yes, sir. I will check.
Yeah. Some MMF wala question. There was some MMF test question was
Week 9, fourth question, sir.
week 9 fourth question.
Yes, sir.
There is 1.2 in fourth.
This question.
Rajini ma'am, how much answer you have? What is your answer in fourth? Are you have same answer 1.2?
So how much percentage they took? MMF in air gap, they took 80% of the MMF per phase. Yeah, so MMF in the air gap is 3500 Tesla. Okay. So the catch is right here. In the option here, they have mentioned that option A is correct, 0.5 Tesla, but with I think they have modified the solution according to what we discussed. So in the question, this statement was tweaked that MMF is 20% more. MMF total MMF is 20. No, they still haven't modified. Total MMF is 20% more than MMF in air gap. So divided by 1.8, it should have been 437. Total MMF is let us solve this. If gap MMF is equal to total MMF divided by 0.1.2, MMF in air gap should be 4375. 3645.83. So air gap MMF you might be getting 3645.83, and after that multiplying with H into 2 LG, is equal to 3645.83. It's H was coming 1,82,000. No, no, 1,822,916, and B will be into 4. Why am I getting 2.29 Tesla? I think last week also we sold. This was week 9, so right, right. So we were getting 1.145 Tesla. Correct answer was 1.1. Oh, sorry, someone is typing.
1.2. Is near
So
about the value is 1.2.
1.2, yes, 1.2. But in option they have mentioned zero point 0.5 Tesla. In solution they have mentioned 1.099 Tesla. I don't know, but 1.2 should be correct. So it should be also be disputed. Number 4, week 9, 1.2 Tesla, 1.145, 1.15. Fifth question, commutation frequency. Yes.
Uh,
Yeah. You have any? You have this different answer, Dr. Patel?
yes, I'm getting same answer, sir. That is
You are getting
correct.
same. Oh,
Yes.
how come? How come?
Actually, solution is not with me because I'm outside. But
Okay, okay.
exactly, I will
Now,
say that my answer that is assignment numbers are 10, na?
assignment number 9, question 5. This you are
One
able to
minute.
see my screen?
Assignment number 9 and question number. hmm, Uh, yes, I am getting question number 5, triple 6.66.
Hmm.
Yes, the same answer, triple 6.66. I am getting.
N to omega commutation frequency was n into omega divided by 2 pi. It anyway, but this expression you had got from the lectures or somewhere else? Like, do you have any memory of collecting that expression?
Yes, sir. I have a Krishnan book, R.
Acha,
Krishnan.
okay,
Yeah, from that I have. I think from that I have collect this R.
okay.
Krishnan.
R. Krishna.
that is specifically for this machine.
I have that book now. I could see. Mm,
Is today Sunday, so my mother home. Otherwise, I have that solution, all the solution.
okay, okay, no issue, no issue. This, this is permanent. Anyway, I have different book, but this was week. I'm in 9, question 5.
Once I will get to my means go to my home, I will share in the disc. Can I share the snapshot in a discussion forum? The
Sure,
so
sure, sure. Yeah, yeah. That would be really helpful for me also. Okay. But the in the lecture slides, from the lecture slides, what we saw, and that was very, common for me as well. Like frequency is equal to, like we all know, n is equal to 120 f by p. Anyway, please share those in the discussion form so that yeah, yeah,
But
yeah.
when we use 120 FIP, the answer is changed.
This answer is changed.
That is, we get F is equal to 333.33 hertz.
Yeah, yeah. That's what we were getting. Exact half of it. Is it week 5 or week 9? So this was the answer, and we were getting exactly half. But anyway, Dr. Patel will share that snapshot in the group so we could see. And also, I'll go through the Ramakrishna book. Let's see how it
yes, sir.
has been.
Yes, sir. By night, I will share in this
Sure, sure.
discussion.
Thanks a lot. Okay, then. Some unaligned problem also had.
Sir, in this question number 10, the pole height.
Yes, yes. Which you two were discussing this. No, no, no. Pole height was, I think, correct.
44.59 I'm getting.
Chitu, we discussed this last week, right?
Yes, sir. The
So
answer is
this
correct.
the answer is correct, right?
Yes.
Actually, Chitu also did some mistake there, and we were
Okay.
discussing last week. So I think you might not have considered some a stator back iron width. So that's why you might be getting some different answer.
Okay, sir.
So verify. Have you verified with these equations and all?
No, sir. Actually, today means these assignments I have not verified.
Okay, okay.
Yeah.
You verify it once, you will get
Yeah.
it correct. I think that aligned inductance issue we were having. I could remember.
Sixth question, sir.
Sixth question. Yes. Sixth question. Motor with 6 poles and 4 rotor has polar. So theta 2 minus theta 1. So is it modified or still the same?
It is, I'm getting 3.587.
Oh, so
That is
has it been modified or is it? See, 10.7 minus 10.5, 5 ampere. We were getting 2.39 if I remember. Theta 2, theta 1. Theta 2 minus theta 1. Yes. Yeah, 2.39. Okay. You do not have solid. Beta S is beta S value is I don't think correct. Yeah. Triple beta S. Plus, uh, 20 degrees. So 20 degree into 5 by the R is 22. 839 beta S 6. 10.71. beta S. You were getting unaligned inductance position, how much, Dr. Patel? Do you have any idea of that, or do you have anything with you?
1 minute, sir. I just go through this. Sir, the solution in the solution, whatever the shown, the same way I have solved.
Okay, okay. Mm, Uh, but in that, this factor is not included, na? कि when the rotor is 30 degree before the line position. Ten to pi by 180, 0.5, 330 before the line position. You got, Dr. Patel, what I'm trying to say regarding that 30-degree angle. So that 30 degree before the line position,
Yes, sir. Yes, sir. I'm getting,
that
but yeah.
that factor is not
So,
included here.
can I propose the solution? Because actually, all these formulas I have taken from this R. Krishnan.
Okay,
Also, I have the soft copy. So, if
okay.
possible, then I will share in the discussion forum
Yeah,
of that book.
no, no, please do not share entire book, because that
Yes,
will
sir.
be, you have soft copy of the book, right?
Yes, sir.
So please do not share anywhere, so because it will be copyright infringement.
Yes, sir. Okay, okay.
Uh,
So, the
uh,
solution which I have did that I will share. Sure, sir.
yeah,
Yes.
never share soft copy books with any other or any
Yes, sir.
online platform.
Yes, sir. Thank you, sir. Noted.
So, okay, so let me write it. Dispute regarding 30-degree angle. Because see, what are the doubts here? The question we solved earlier, generally what is given that a stator pole arc, whatever the value is, the same by the same value, the rotor is before the line position. So that is why in all other cases there might not be any issue, but when these two values are changing, then we have to be careful, and that's why what is creating issue here. So anyway, if possible, I also have solved this problem, so I could also share my snap. Week A, week 9, question 6. So in that case, when both are equal, then we could straight away take beta s, La minus Lu divided by beta s. But the position between aligned and unaligned does not remain same when these angles are different. Whole arc. Do I have any SRM examples? I'll tell you.
DL by d theta, I think it should be 1.25.
DL by d theta should be 1.25.
Now we have to multiply by 1/2 into I square.
DL by d theta, you are saying 1.25. Yes. Let me see. How much did we solve? With 9, so it must be solving with 10. Anyways, I'll share the snap of my solution. Okay, I was just trying to show you what happens with unaligned and aligned.
Hmm.
So see, the aligned will be definitely this stator,
Hmm.
but not always. If suppose your rotor pole is shorter than your stator, then it could not be entire aligned position. Why isn't it stopping? Just a second. Let it get completed so that I could. Yeah. So see, this rotor teeth, its width, when it is equal to the stator teeth, then only entire aligned position will be a stator teeth, right? And beta r plus beta s is not always equal to slot pitch. Let's suppose key this position. Okay, so this design is exactly equal to that. Let's suppose if we take and do the provider and yes, yes, yes. Just slot pitch, rotor pole angle, stator pole angle. See, both are considered as equal. That is why it is completely getting aligned. Let's suppose if you considered it as 20. Now it is shorter, right? So when your rotor, even rotor will be aligned, but not entire stator tooth is getting aligned. Aligned means entire portion should be having maximum flux linkage. So that's the issue with that question. I hope you are getting my point. Why what I'm trying to convey here.
Yes, sir. Getting this
Yeah,
point.
yeah.
Yes, sir.
So if like that. So we will discuss there, and yeah. Yeah, so question number 6 has to have a discussion there. Any other problem from this assignment? Question week 9. तो ये तो this is तो
4, 5, and 6, sir.
5 and the 6. 5 and 6. Yeah, this 5 and 6 we have discussed, right?
Is 1.2 that we have discussed. Yes, it should be 1.2.
Yes, yes, yes. So see what I was trying to refer. Question number 3 and question number 6. They are different in which way, right? If have you got correct answer for question number 3, Dr. Patel and Rajni, Chitu?
I think 0.428
Mm-hmm.
in the question number 3.
So I think you guys must have also got the correct answer there, right? Why? Because here the stator pole arc and this rotor position before the line, that is same. That's why these all juggleries were beta s is coming out to be equal to that, right? So just analyze. Right, correct. So that's why I think they had selected these two problems carefully, but solution they generalized. But anyway, so that's the issue. Yeah. Uh, G2 question 5 and 6 we covered, right? You are referring to the same week or any other week?
Same week, sir.
Same week.
That
Question number
is
5. Question 5 and
formula,
6. Sorry.
formula for finding commutation frequency.
Yes, yes. That these two questions we have to post on the discussion form, and this also 4 also, right? 4 also, it also require option D should be correct. Question 4 I have written. Yeah, I have written question 4 1.2 Tesla. Question 6 and 5. Question 5 question 5. Commutation frequency should be half of the answer. Yes. So I think these 3 problems from the week 9 were there, right? Any other?
Week 10, 10th problem, sir.
10th problem of this week only.
Week 10.
Week 10. 10th problem. Electromagnetic torque generated. This I have already noted. Week 10. The 0.533, right? 0.533.
Yes, that we have discussed 0.533. Yes.
Okay, so that's all, or any other things so that we could start our session?
Yes, sir.
Okay, that's okay.
Yes, sir.
Yeah. So I hope you might have gone through the week 12 lectures, right? And it is based on nothing but the simulation of FEM, right? I hope you are aware with the software FEMM. So why this software is encouraged in this course, like many uh, in many enrolled students might not have access to any paid software. So to understand the basic, it is very much useful. It is an open source software, and it is really very simple to model anything. Or it could be coupled with any software, MATLAB, Python, anything, right? Mm, Assignment problems are directly related to FEM. So, and I don't think much problems are there. Three, four questions are only there. If you just even search on the Google or somewhere else, you will get your answer. So, have anyone been with this software, FEMM, before, or if you have heard or something?
Yes, sir.
Okay, you have tried this software?
Uh, FEMM I have not used, but as I told you, ANSYS Maxwell means somewhat, and the console I have used somewhat. Not in a deep, but the basics only. Yeah.
Okay. So, FEMM in that way, it is a pretty, as I said, but it is very old school kind of software. It is not very much user friendly kind of interface. So it has such interface. Let me open new. If you are solving any magnetic problem, you have to open here, right? Now, there are very limited options here. You could see here on the top of the tab. So you could go through, and it has a website. Let me show you. This is the website here, femm dot finite element method magnetics examples, right? So you could pick any example, right? It would be better to go with the first example, magnetics tutorial. You open it, you will be able to see how to model this kind of air core coil, right? So step by step things are mentioned. Like see here, let me zoom it. So first task is to tell the program what sort of problem is to be solved, right? So select problem from the main menu. Problem definition will occur. Now, how to draw something here? So switch notes mode by pressing the operator notes toolbar. Okay. Tutorial, complete tutorial FEM. Here it could be download. Okay, so these are the tutorials. I am just referring this website. You could go through and you could look at each properties and step by step, right? So something like this it should look like after modeling all those. It is basically node by node you have to draw. You have to create multiple nodes like here. This is one node. This is other node, right? So two nodes I have created. I hope you are able to see this. Yeah. Okay. Yeah. So these are the two nodes, very small nodes. One is here and other is here. If you want to draw a line, then you have to select here and select here. So this line is joint, right? Now, if you want to create something else, you again create some other node. Okay. Now, if you want to draw an arc, click here, click here. Now, arc angle, how much it should be? Let's suppose 30 degrees. maximum segments, uh, let's suppose 2. Okay, so this is how arc is designed. If you change the angle of arc will change and all. Circle also you could make, but everything has to be done with the help of not such a user-friendly environment, but still you are getting in free, so that's the thing. Now to assign any reason, if let us suppose I have to again draw a line here, an arc. Okay, center start end. Center start end is okay. Yeah. Now I'll place a node here. Right. This is the material. The green one is for the material. Right. Now you could assign material with a property, add property, no, for materials. So this is a tab where you could add material, boundary, point, circuit, or this is the library which materials are present here. Okay. So these are hard magnetic materials contain all the permanent magnets, alnico, NdFeB, the grade of alnico, the grade of NdFeB, right? Regarding soft magnetic material, we have different kind of materials, which means cores. Soft magnetic materials, which refer to the core. And here, which kind of silicon steel? M19 to M47, cobalt iron, Hippo and vanadium, right? So you have to bring it here and like that. So now you have brought your materials in the library. Now you could see here, and it is add property, modify property. So there must be some tab for the materials. Property for all labels. Hmm. So you could delete the node from here. I forgot how to assign the material. It was pretty easy. Operation, arc segment, block, grid problem. So the first thing is that you have to define the problem, whether it is planar or asymmetric, axis symmetric, right? Then length units you have to set in millimeters, frequency whatever you want to set, 50 hertz. Depth means axial length, how much axial length do you want? So 10 mm. Minimum angle for which it should be designed. So 30. Smart mesh on, otherwise you could manually give the mesh, or like in certain software it could automatically optimize the number of meshes. So like that it will do. Yeah. So why all these tasks like drawing customize is not very much appreciated nowadays because of the presence of scripting. So see, many of the functions of manual drawing and manual assigning of materials I also forgot. Why? Because we are very much used to of a scripting. A scripting is something that you write it and it will just become available on the screen. So that's one example I'll give you so that we could generate geometry and assign materials and what are the codes corresponding to that. So if you might have gone through the lecture, you might not be seeing any instructions related to drawing and all. You might be seeing related to all the MATLAB codes. So what that is doing actually, let me open one example here. So we will be solving for the bar magnets. We will be seeing the characteristics of bar magnet, and then we will be seeing the characteristics of entire motor design. And other very important thing is that if you have any CAD file, you could directly import the CAD file, right? Import DXF, and then you could provide all the material section there. So that is another way to do. So first, let us go step by step with a bar magnet, how to model it with the help of code. So where you will be writing code, or in between, I am just speaking continuously. So if you have any doubt in between, please feel free to stop me and we could discuss that. Oh, like, yeah. Here it has a console of Lua script. So it is basically connected with a scripting interface which is known as Lua script. So uh, here it has a console. Either you could import the Lua file dot which is basically in the form of a notepad kind of thing, or what you could do, you could open a Lua console here, right? And you could type here anything, right? So what to type here? Yeah. So let's suppose we have to draw a line. Okay. So how to first start with? So for any new file,
Sir, your voice is not audible, sir. Sir, we are not able to hear you, sir.
Yeah, hello. Hello. Am I audible now? Is it better? I'm using my
Yes,
phone.
yes.
Yeah, yeah, thanks. Thanks, let this. Yeah. So did you get anything like while I was creating dots and drawing the line on the interface? So anyway, if that should not be any concern. So here, what are we doing? We are using a scripting to get it done. So what you need to do, you just need to write couple of lines of codes and it should draw there, right? So this was nothing but we were defining the problem. Zero means, creating magnetic problem. The first on I showed here, if you are inserting zero, then problem is like planar, right? No, no, no. If you are creating a new file, then this is the zero. This is corresponding to zero, magnetics problem. Then electrostatic problem, heat flow problem, current flow problems. Right? After that, what units do you want? Millimeter, meter, right? So that is also there. Apart from that, yeah, apart from that, how much accuracy do you want? So if you increase this accuracy points like places or gaps between the meshes, that is the unit here, right? And this is for 2D. If you are inserting zero only, that defines for 2D. And this 30-degree is nothing but the angle between the different meshes, right? So this much initialization you have to do. Now, if you want to, create a line in it or anything, you have to, you know, define it. So let's suppose uh, to draw a line for the. So define first x1 is equal x1 y1 and second line should be x. So from x1 y1 to the difference between 5m. So this could be either in, you know uh, Cartesian or it could be in, right? So it depends. So x1 is 0. We will use dollar also in the slides or the later on course. X2 it should be y1. X1 y1 is equal to. Similarly, 2 is 5. Okay, on horizontal axis, y2 is equal to 0. Okay, if you want at certain on a certain distance on y-axis, also give it from here. Right? Now, the important thing is adding node. Adding node is very critical here because that will define everything. From node, you could connect to anywhere. So to creating node here, there is a code for that. That is mi add node on the first point. So which one was x1, y1? Okay, we have created a node here for x1, y1. Please interrupt me in between wherever you are getting any doubt. Okay. Second node where I will create at h2, y2, right? So this much we have created. Right? Now, what is left? We have defined the 2 points. We have created two nodes, right? What is left? To make a line, what is left? We have to connect with the help. So line is known as segment. Mi add segment from y1 to x2, y2. Okay. So now we have joined the line.
Okay, and let's evaluate it here, right? So you can see clearly that one line has been created. Okay, so this is your all code which has been compiled, and here you see that actually its user interface is not very user friendly, but still you could see this line, right? Where did it go? Yeah, this is the line. Right? Any doubt? So far, so good. Okay. So now we have to, you know, make a bar magnet. So what will comprise in a bar magnet? What all quantities, what all things we will need? So first we need a rectangle, that's for sure. Then we need to, create a node there. Then we need to assign material there, right? So that all we need. So which kind of material we will be needing here? One is we must have a permanent magnet. It must be available in this library. Other thing is we should have air also. Is the impact in the air. Now, just draw the again in this console. This is console. If you want to use this line, that is fine. But if we want to draw a rectangle, we could quickly draw it, right? Just with the we should clear this output things. Now we will again start with the first line. What was it? New document. So that is same as old. Mi drop definition 0 millimeters container it again 0. Okay, 0 then 30. Two line will be mostly it will remain same. Now important thing is to load the material from the library. Okay, so for that the command is mi get material. First is air. Air is written whatever the name in the library you have to write as it is. So let's see here. Preview. Where was it? You could add also, but that's a concern as of now. What is library? Yeah. So air is written like this. So this is air. BH characteristics you could see relative mu are given. So not laminated, not a standard. And so this is air. So that's why we have written it like that. Okay. Now the next thing is the next material should be permanent magnet. That is in NDFEB, which grade you could take. Again, go to the material library, see hard magnetic materials, entered NDFEB. Okay, N30 is the very basic, or you could select any other NDFEB grade. N30, you could see here the properties, right? So HC is given, right? Electrical conductivity is given, mu x is given, mu y is given, which means mu r, right? pH curve linear. Non-linear zone, we are not Actually, it is not mentioned here, but you could also model it if you want, right? You could edit here and you could enter your own file so that all the editing and customization facilities present, right? So far, so good.
Yes, sir.
Okay. Now, yeah, I have to write it in 30. Now, the next thing is draw the ball magnet. So let's suppose the ball magnet is some wide or it has some width and some uh, length. So we should have we should directly draw a rectangle. Okay, rectangle. So it should it should go from five, like how much tall and how much width. So x1 y1 to x2 y2, right? So it should have -5 to -15 to +5 to +15. Why like this? From the negative top edge to the positive top edge, right? So from -5 is the x lower side and above is 5. So this is corresponding to x1. This is corresponding to x2. So the width is 10 mm. Now how much is the length? So y1 is -15, y2 is 15. So overall length is 30 mm. So this will give you a draw a rectangle. So let's see parallelly also, right? Let's line two thing has some errors. Yeah, so it is giving you like this. So error is like, okay, we have error in line two. So we have to again check line two. This is a line two. So here one string is missing, right? Millimeters. And evaluate, and we could see that this rectangle has been created. So this is the rectangle, right? Any doubt here? Are you getting?
Yes, sir.
Now, if we have created rectangle, now what to do next? Keep first so much thing as it is. Now we have to create a label, right? So we have to first create a label, then we have to set that label, and we have to give magnetization, and we have to assign properties, right? So we will do all these things. First, we will add block label. Block label means we are going to assign permanent magnet. So we are making this rectangular block as a permanent magnet. So mi add block label, okay, with here 0, 0. Why 0, 0? Because 0, 0 will be center of this rectangle. Yeah. After that, we have created this label. Now we have to select that node. Then only we can assign. So select label with 0, 0, the same label, whichever we have just created. Okay. Now, text. Now we are going to define that with this material, whichever we created, right? So mi text block properties with M30, the material which we created, then it 0, yeah, so yeah, one is here to automate the mesh sizing. So here we are not concerned with the mesh sizing of the material. Okay. Or, or you could keep it 0 if you want to, manually assign this mesh size in the next parameter. So let's suppose key you are giving first, let me complete this line, then we can discuss it in detail. 0, 0, like this. 90 is the magnetization orientation, then again 0. Yeah, so what does this line mean that I'm going to explain? The first thing is clear, that is magnet grade. Now, second, 1, 0 could be replaced with 0 and something else. So, one is auto mesh, then manual mesh you have to keep as 0, the size of the mesh. If you will replace one with 0, that will assign as a manual mesh. And now, for the mesh size, here you will have to define. So this 1, 0 is changed according to your requirement. Okay. Now, these quotes are there to assign any coils. If there are any coil will have current circuits, something like that. That should be there, right? So that assignment has to be there. But in permanent magnet, no coils are there, so we could keep it as a blank. Next is 90° or something. So it is a magnetization angle. How much magnetization degree you could give. So here, if we are giving 90°, which means along the plus y axis. So magnetization should be here from the bottom to top. So this should be the magnetization orientation, right? And the next is again related to circuit or number of turns, and also since this is a permanent magnet, it should be 0. Okay. Any doubt here? Now whatever we selected here, here we selected level, right? Mi select level. So we have to unselect now so that we could switch to another block. Mi clear selected. Okay. So this is all about creating node, assigning material. So from here directly we have assigned the material. So we do not need to play with anything on the interface. Now, this is a magnet, but to observe the impact of magnet, we should also have some air, right, inside the air. So we have to create a boundary with air region. Okay. So for air also we will have similar things like rectangle. So we have to draw a rectangle again. We will just copy this line and we will draw a bigger rectangle, right? So since it was -5, 15, means 10 and 30 mm. So we will create almost double or triple of that, right? So that should be like 50, 50, 50, 50. You could straight away take minus 52. Y is also minus 50. Any bigger air, however you can create, that should not be an issue. 50, 50, 100, 100, whatever value that comes to your mind, you could create. Right. So it is a 100 mm of air boundary. Okay. Now again, we have to assign air material also, right? We have to do the same thing, assigning. So again, we have to add block label. We will copy this, right? With again paste here. And where should be node now? Node should not, align or should be in the same region where magnet is there. Right. So node should be the out of the magnet region. So you could provide anywhere. Let's suppose key this is 30 30. So beyond 30. So 40 40. Yeah, you provide air in the 40 40, right? So add block level in the 40 40. 40 should be within the range of the. Yeah. Now we have to select the same level, right? So again, we have to copy this 40 40 to the select level. Now, what should be the material now? Material should not be in 30, it should be air, as we have already defined, right? Now, remaining all you could keep, but air does not have any direction, so you do not need to give magnetization to the air, right? So we have assigned materials, all the materials, right?
Yes, sir.
Now let's see what has happened. And two are still, acha, yeah, this is still again, 19 again, it's a bit. So something created air in 30 and meters, no problem. So I not it that. By two. Yes, yes. So now here you can see, okay, it further overwritten that initial line, but you could see this magnet with magnetization here and this air region, right? If you want, you could delete also this one. And then let us select only the last section of our code. We will delete all those inputs. Clear input, clear output. We will those windows. Yes. So you have to zoom out to see into okay, anyway, let it be. So this air is still coming there. That should not have happened, but it's like this. Okay, so now we have created everything. What we can do we can save all and everything. Console. So we could enter the next line of code as mi save as something if you want to save it. Save as bar magnet. Okay, now the important thing is to analyze, right? That will run the simulation. So mi analyze, yeah, nothing is magnetic on it. Then mi, these are the lines to solve it. Mi load solution. In the end, I'll share the code with you, so you could also take a look on the code and you could simulate on your own. Okay. Now, mi show density plot. So it will show you flux density plot or whatever you want. With 0, 1, 0. Also, I'll explain that if it is not done today, in the next session also we could explain it further. City plot and an output. Yeah. Input. Save. So we are getting error here because we haven't created boundary condition that is required, right? First line, limiters need of this. So we have to create boundary condition in between before the solving. So for that, we have to include all those Dirichlet conditions and all, which you might be seeing in this assignment problem. So am I add boundary? This will have first I am completing this line, then I'll explain this line. What does it mean? A, okay, 0, 0,8, 0, 5, 4, 9. Okay, yeah. So these all line this line which has all those zeros that is corresponding to different boundary conditions. What are those? First 0A means no Dirichlet boundary condition, right? So first is corresponding to Dirichlet boundary condition. Second is related to Newman boundary condition. Third is corresponding to Robin boundary condition. Fourth is corresponding to periodic boundary. Fifth is no surface current. Sixth zero correspond to no prescribed value and like that. So you could, search from the user manual, which is given on the website. You could see what all this text refers to, right? So this is how you have to provide the boundary condition here, right? After that, what you could do, you could select the uh, boundary, what to call. boundary limit, right? So that limit should be like this. You have to select all those boundary extreme lines which we have created as air. Mi select segment. So first was at minus 50, 0, right? Second was at plus 50, 0. We have to assign all those boundaries. Now, similarly, we have to do with y-axis. So that will be 0, 50, 0, minus 50, 0, 50, 0, minus 50. Okay. And now, again, get segment of this property which we added, boundary. So set segment A. Segment. Okay, so again, what does this mesh size, this second one is the mesh size, which will be automatic, right? Uh, this is again number of turns and boundaries, which I have commented everything. If you go through the code which I will share with you, in comment you could find all those explanations. And after this setting, put clear the is selected. Okay, so I hope we are more or less at 71. That level. Okay, so this code I have copied in the notepad also. So what I'll do, errors are there, sort it out later. I'll load here, open Lua script, and this is the a script for the bar magnet, and this is how it will look like, right? So you just see all the significance of the code, and once you done, it will look like something this. So this will open in this text. This is the notepad where I have written everything to simulate it. Just to go through it. I'll say where I'll just say the chat box now. That through it. Yeah. Okay, so I hope you will be able to download it and you just run it on your own. If you haven't installed this software, install it once. You go through the each line wherever I have explained, or you could also search online, and this is how you will be able to see the flux contour. So as we assign the magnetization in this direction, you can see that it is going from here and coming from here. You could also see like different plot if you want field intensity or something, but since no current is assigned, so we couldn't do anything. Meshes you can see, these are the meshes. These colors also you could change. And so stress tensor mask, if you want to, you could, play with different options. So like, okay. So this is all regarding this week. Okay. Uh, and if I have to ask you one more question,
Yeah. Sorry, I was muted. So, if you have any doubt, we could discuss next week. And so, any suggestions for the last week topic? Do you have anything in your mind? Because next week will be the last week. All it is probably on the Wednesday. So, do you want me to continue this FEMM software, or you want anything else? Uh, Actually, I have forgot. You will receive mail. I think it is from same. I think I have kept timing same 3 to 5 only. Might be 6 to 8. Sorry, I have forgot. There was lot of things, so it was asked long back. I am not able to find my extra session. Acha, it is on Wednesday only. I think most probably 6 to 8, which I can remember. Okay. And there are plenty of tutorials for FEMM on YouTube also. If you'll go there, you'll find. But that is related to the drawing. With the scripting, I did not find much. But with MATLAB, I think again you will be able to get some. But MATLAB requires licenses, so that's there. But I think Rajni, you have the license for MATLAB, so you could explore that also. But there is nothing wrong with this Lua script. Only thing is that it is a bit old fashioned, so no maintenance, and also that's why user interface is not good in FENM. Okay then, so it's time to conclude. You'll receive an email. Thank you very much for joining. Bye bye.
Thank you, sir.
Thank you. Bye. Good night. 3256 is okay. Okay. Uh, okay. You'll receive the mail because the form was filled a long back. So now we cannot change. But I think it either 3 to 5 or 5 to 7. I don't know what.
Uh, 5 to 7 or 6 to 8 will be okay, sir.
Okay, na? Okay. Great. So it is in this range only. Most probably, I have tried to keep in the same slot which we have been doing 3 to 5. So I think it should be okay.
Because
Yeah, yeah.
we have college, sir.
Ha,
3 to 5
ha, yeah.
only.
Yes, yes. I know. You have, but this was the last. So we had deadline to finish it before April 16th. So no weekend was coming in between. So either I had to take, because this session is on Sunday. So either next session would be on Monday, Tuesday, or Wednesday. So three options were left only to me.
so that's why I couldn't do there much. But
What I think at that time, like 3 to 5 or 6 to 8, I don't know, but these are the two slots only. But any recommendation for the topics what you want to get covered in the last week? Like, shall I continue with this FEMM stuff?
Sir, the simulation, the last 2 weeks, week 11 and week 12, sir.
Yeah.
Theory part,
Week 11 and week 12 are mostly related with simulations, right?
yes, sir.
Yeah, so you want to get covered these things only, right? Okay, okay. Like all these Dirichlet conditions and I'll prepare one. Okay then. Week 11 and week 12. I'll keep that in mind. Assignment questions clarifications. Which week do you want to Rajni? Which week's assignment clarification? Like, acha, you are saying that on the portal definitely I'll post all these issues. Okay. In this session, okay, anything is there assignment question? I don't think any issue. We have all those solutions and we have all those concepts. So any issues are there, we could sort it out in that. Okay. Regarding assignment questions, there should not be any issue. Okay, and try this software, right? Try this software. It is good software. The image already equipped with Flux and ANSYS, so you will find interesting this software. Titu, have you tried any other software before that?
Yes, sir.
Okay,
This is completely new.
okay, okay. No problem, no problem. It's very basic. Just go step by step. And nowadays, a lot of help are there. Anyway, we are going to discuss. Just try to simulate something circular and try to simulate some model kind of surface mounted or so. Or if you are not very comfortable with scripting thing, you should try these options of drawing the curves and all. That should also be similar to the CAD drawing. Okay, so we will see if any assignment questions are there. Otherwise, we will continue with this. Sure. Otherwise, we will continue with this FEMM thing and all those concepts behind boundary conditions like Dirichlet, Newman, all just I said that we can consider. Okay, then. Thank you very much for joining. Have a great weekend. Good night. Bye.
Thank you, sir.
See you. Bye.